Hello, this is Brandon Johnson along with Antonia, Lucia, and Aaron from Group 1, and this is our final design presentation. The presentation shows our alternative concept designs along with our final selected design and explains our methods for evaluating each design with preliminary results.
This is the open view of our selected final design. First, to collect the program modules, this design uses an improved version of the subsystem tested in week 9. On each side of the base, a system of 2 hinged arms fold out after being hit by an actuator. As they fall, the sweepers open out and fall past the programming modules. The actuator then retracts to bring the modules into the home zone. Then the drawer slider moves forward out towards the matrix. As it extends, the hook on the bottom catches the sentinel and holds it slightly above the track. Once fully extended, the PVC tube places the pills in the correct sections. The sections are identified by a long-arm sensor that reads the beacons. Finally, Morpheus is rescued by the grabber. The grabber rotates forward so that it comes down directly over Morpheus. Morpheus is then stuck in the bristles of the grabber, which rotates back to its starting position, and the drawer slider retracts back to the starting zone, bringing the sentinel with it.
This design uses foldable L-shaped arms that drop behind the programming modules. It pulls them in once the actuators retract. Both the pills and the Morpheus rescue arm are extended into the matrix using a scissor mechanism that is also mounted on a vertically pivoting base. The sentinel is retrieved with a hook that is dropped just behind it and pulled back separately from the arm that placed it. Although this design has an efficient use of space, its major downfall is the lack of vertical rigidity when the scissor mechanism is fully extended.
The second alternative design has the arms for collecting the programming modules completely folded for increased speed and utilizes a multi-layer drawer slider system to reach the matrix. The pills are delivered to the matrix with 2 buckets that each hold 2 pills to be placed in each red zone. The arm located on the top of the design is used to slide Morpheus into the team zone and off the pedestal. The bucket delivery design for the pills has slightly disadvantages, with the front of the buckets falling backwards, putting the pills farther from the lip of the matrix. The Morpheus retrieval arm also lacks the ability to retrieve Morpheus all the way to the home zone, limiting the scoring potential of this design.
Alternative design 3 is shown here in the open position. Like the previous designs, the arm and sweeper systems extend first to capture and collect the programming modules. As the drawer slider extends, the center bar below pushes the sentinel forward into the blast zone. At the extended state, pills are placed into the 2 red sections of the matrix. They're released by a wheel that lets 1 pill roll out at a time. The Morpheus bar opens up over the matrix and then pulls back to knock Morpheus into the home zone before the whole system retracts back to the starting area. The biggest downfall of this design is that Morpheus can't be brought all the way back to the starting zone. He can only be knocked into the home zone.
Design 4 features a claw mechanism for the retrieval of Morpheus. The mechanism for delivering the pills mimics a merry-go-round, which spins as it delivers the pills into its appropriate zones. The sentinel is engaged using a hook mechanism under the main arm to sweep the sentinel back into the home zone. All of these mechanisms rest on the same ejecting arm, which uses a door slider. The mechanism used to gather the program modules is a wedge that swings down from above the arms to knock the modules into our zone. The mechanism rests on an arm that swings out, rotating from a joint at the base and another midway up the arm.
This is the most simple evaluation matrix. The first design is used as a benchmark to compare the alternatives to as same, better, or worse. The results show that every design has similar scores and no major changes needed to be made to move forward.
The second level evaluation matrix is shown here. It compares each design individually to the requirements. It shows that the chosen design had the highest score of all designs considered, an 88%.
The third level evaluation matrix is the most in-depth and important for picking a design because it factors in the weights of importance from the House of Quality for the competition requirements. Here, the chosen design scored a 90%, 6% higher than the next best design. Because the design for program modules was successful in the preliminary competition, it was used in 4 of the fine designs shown here. So, each alternative has the same score for this requirement. One of the most important factors in selecting the final design is the requirement of scoring the most points. It is weighted heavily, and only one design scored a 4, the chosen design. The alternatives have low scores for this category because the mechanisms for the Sentinel and Morpheus are not the most accurate. In the alternate systems 2, 3, and 4, it is impossible to bring Morpheus all the way back to the starting zone. The inconsistent reliability of the Sentinel engagement also accounted for lower scores. The preliminary results are promising. In the first competition, the module subsystem won, scoring 133 points and collecting 63 to 88% of the modules. We've kept track of what the machine typically completes when running, so we currently expect to score 129 points. That is about 70% of the possible points, so we'll continue to improve that number.